Hi, I'm Vagrant Cascadian. This is Héctor Orón. We'll be talking about RISC-V and Debian, in particular finding the bits and pieces. So, uh, you've heard our names, but who are we actually? Well, I'm a Debian developer. I currently maintain a build farm for reproducible builds. And Héctor, who are you?
Yeah, I'm developer. I'm a part of several Debian core teams, and I was involved with the RML and RMHF Debian ports. And now we thought it was time. Yesterday we were just talking and said, you know, there's this RISC-V architecture coming up. It's quite cool. It's an open hardware. There's some people interested, some other people that doesn't know what it is. Maybe you should do a talk about it and discuss with the Debian community. So we just decided yesterday to plan for this talk, and here we are.
So, I'm guessing most of you pretty much know what Debian is, but just in case, or for those paying attention online, Debian is primarily a volunteer-driven effort. So people who do work make work happen, and things happen because you're helping. Yeah, Debian. A Debian port is basically a Debian built for a particular hardware architecture. Generally, there are some exceptions. And currently, as of Buster, I think there are 10 official ports and 11 unofficial ports. And the unofficial ports are kind of like ports in progress or ports that used to be official ports that got removed, but still have people interested in trying to keep them working and maybe in theory getting them back into Debian. And we also have two kernel ports to the K3BSD port. So we're going to be talking about RISC-V 64, which is a bit of a mouthful. And that's one of the newer ports in Debian in progress.
Okay, I'll go a bit of the history. I may not be right on some things, but hopefully you get the full idea. So around August 2014, it was the Berkeley University published the instruction sets should be free, and they created the RISC-V. RISC-V there was RISC-1, RISC-2, and it was the Patterson and Genesi. I don't know if you know these guys from Berkeley University. Patterson is involved in this architecture, and they were standardizing an open architecture. So the revision of the standard, they got up to RISC-V. And before that, there was open RISC development, which I think there's some synthesizable core in open cores, which was OR1K, that you could deploy on FPGAs or things like that. It was an open core, it was a RISC architecture, but it was 32 bits. And when the tool chain upstream was not quite good to accept all these patches for OR1K, and then the RISC-V came up and kind of killed the effort on the open RISC side of things. So in the slides, there's a link. So okay, it doesn't come up here, but you can, if you get the slides, then you get the link to the instruction set, and then it was an article published the case for an open ISA and why we need an open standard for SOCs. And then Low Risk appeared. It's an open source silicon company, and they wanted to do hardware, open source hardware. So they joined efforts with the Berkeley University, and they kind of push with the RISC-V Foundation. So what happened on the Debian side on that? Manuel Montesello is a Debian developer. He's not at DebConf, but he was pending of the OR1K and following all these developments, and he was like playing cross-compiling code for these architectures and trying to get toolchain support for them. So he started to cross-build and play around with RISC-V around 2014. And the GNU toolchain support was expected to be by 2015, but it took a bit longer. It just around 2017, they finally got the RISC-V support on the GNU toolchain, mainly because there was some delay on the copyright assignments from Free Software Foundation. But all that got resolved, and nowadays we have like a properly supported toolchain. And Debian RISC-V was initiated as a cross-build bootstrap, so it was a cross-compilation. It was the initial set of packages. Those could be buggy or not, but eventually Manuel and other developers like Aurelien Jarno or Carsten Merker, they got real hardware due to a company called Sci5, and they switched, and also they switched to emulated builds because QEMU got support, so they switched to build natively. So cross-building uses your host tools like CMake or Doxygen, and when you switch to build native or emulated systems, then you need to port all this part of the stack which was missing. So switching from the cross-build packages to the native emulated builds, it was also a bit challenging and showed part of the issues with the stack. And around 2017, in April, well, people was asking about RISC-V, and then Manuel decided to open up the repository he had. It was incomplete, it was work in progress, but people just wanted to have a starting point. So nowadays, we have a build infrastructure in Debian. We have emulated builds with QEMU. We have around 21 machines, which are sponsored by MIT, CSAIL, and OSU, OSL in Oregon. And we need to thank Data Neutral and GCC Compile Farm. So we've been running with the port with these machines up to April 2019, which then we switched to real silicon. So we are currently have 5 Sci5 machines. 3 boards were donated by Sci5, and 2 boards are donated by Mulbad. It's an OpenVPN provider, and they are hosting this for us. And we're looking to expand the farm. And for now, we are keeping up, but we still have the QEMU machines. They're off, but if we need them to keep up with the builds, then we turn them on. But so this is the last 2 weeks graph showing the keeping up. So the top architecture keeping up, almost building hundreds of packages in the last 2 weeks has been RISC-64. So the package auto build status, there are 12,023 packages already built in the archive. There are around 1,235 packages waiting for toolchain fixes, like LLVM, spending some patches there, and multi-arc support, and Rust as well. And there was some failures, and then 28 packages in unreleased suite, which need to be merged in Debian eventually. So far, that means that we got around 88% of the archive, the Debian archive built for RISC-V already. So which give us around this. So we have the same amount as Motorola 68K and a bit more than Alpha. This is the tool chains we're waiting for LLVM to complete, and we target RV64G by default, no floating point, and LLVM block support for Rust at the moment. You can run a GNOME desktop already on RISC-V hardware, so from unstable. And yeah, then there's some hardware enablement bits that you may know about that Vagrant will continue talking about.
So ARM is getting a little too conventional for me, so I decided to start packaging firmware for RISC-V as well. I'm the maintainer of what I believe to be the only RISC-V specific package in the archive, which is OpenSBI, which is kind of like a pre-boot firmware kind of thing. And also recently enabled some targets for U-boot that are RISC-V specific, including a QEMU target, which I demonstrated at my very exciting live demo yesterday. And I believe there is also work ongoing to get support for core boot on RISC-V and also some EFI implementations. And the Linux kernel packages in Debian do build a RISC-V variant, but there are some kind of pending patches in process that we've pulled from upstream versions, and the most recent kernel we have in the Debian archive is 5.0, but come 5.3, we probably won't even need any RISC-V specific packages or patches to the Linux kernel. So that's looking pretty exciting. And because all the pieces are starting to line up, Karsten Merker has done a lot of work on getting the Debian installer support enabled. So it still has some work to figure out exactly what kind of bootloader we're going to use. In the past, RISC-V was typically booted by compiling what was called BBL, and you compiled the Linux kernel as a payload to this bootloaderless firmware environment. But I'm the U-boot maintainer, so we're working on some U-boot support for RISC-V so that you can just boot a regular kernel. Very exciting stuff, I'm sure. And then there's also some, Karsten Merker put together a UDEB for the U-boot menu installer so that it can generate an actual boot menu. So if you flash the wrong firmware, or you flash a firmware and it has a few kernels to choose from, you could maybe boot a kernel that used to work rather than just the one kernel you have access to. But there are a couple changes to the kernel packaging needed in order to take advantage of that menu-based installer. But those should be upstream as of Linux 5.3, so we might not actually need to make changes if we wait till then to upload a new version of the kernel. And really, the RISC-V port has kind of been stalled, but as many of you know, we released this thing called Buster, and we're working on this thing called Bullseye, and we can finally get some patches that were pending for RISC-V, so new features are again flowing into the archive, and I imagine we'll be seeing more and more fixes to RISC-V. It'll be getting improved support over time. So you too can use RISC-V in Debian. I mentioned that there's support even for the QEMU and Buster, so you don't even need to be running unstable, although before too long you'll probably want to run the latest, greatest QEMU. So there are a few contact points. There's a wiki page which documents the various ways you can set up and install RISC-V. There's a mailing list, Debian RISC-V at list.debian.org, an IRC channel on irc.debian.org for Debian RISC-V, and of course, I guess also a low-risk channel on OffC as well, and just the general upstream channel for RISC-V development is on Freenode. So Want to have a big thanks to Debian for being such a great project to develop a port on, and Manuel Monticello, Karsten Merker, Aurelian Jarno. Those last three names are probably would be more appropriate to be standing up here on this stage and answering all of your amazing questions that are about to come. But they couldn't make it this time, so Manuel left a very nice comment encouraging you to take a look at this project. So basically, we're down to questions, I would think. So, any questions?
Yes.
What kind of hardware is available?
So the hardware available right now is very limited. You can get the Hi-Fi Unleashed board that we have, that I believe Sci-Fi donated about 5 of them to the project. They run at around $1,000 for a board that's maybe about as fast as a Raspberry Pi. So this is a big problem for RISC-V right now. I think I hear rumors of plans in the works to actually do more like real server-grade hardware, but we all hear about this sort of thing fairly often, and we'll believe it when we see it, although I'm really hopeful. Because it's an open, one of the most interesting things about the architecture is it's an open instruction set. So really, anybody who wants to give it a go can actually build a RISC-V chip and maybe make some tweaks to it, make improvements to it, just like with free software, only it's hardware and therefore hard. But yeah, there isn't a lot of hardware available right now that's actually Linux capable. A lot of the developments are in the IoT space, so they're lower performing, almost microprocessor level type stuff.
Yeah, so the main board is the Hi-Fi board, and then there are soft cores like Rocky that you can run on FPGAs, but it's very slow. It's more like development thing, and there might be hardware coming up real soon, but we don't have details on that. So, but we are prepared. Debian is prepared to get this.
I think it's a tricky thing with a new hardware architecture too, because you don't really want to invest a huge amount of billions of dollars in a piece of hardware if you don't have software to run on it. And you also don't really want to invest a ton of energy in developing software for hardware that may never exist. But But we're at a point where the emulators are good enough that we have gotten to a point where we've built, well over 80% of the archive, and so there is software available now. So I think we're at that point where hardware might be coming because there's something to actually run on it.
Yeah, last year we were at Hsinchu in Taiwan, and Andes Technologies show up, and they're also like building microcontrollers. Hardware based on RISC-V, which is also they have the microcontroller and more like a CPU, desktop capable to run a desktop. What I mean, but the microcontrollers, they are already used in production in the industry, like in the network cards or hard drive. Western Digital is a good contributor and to this architecture. They're putting this in the hard drives, and it's already being used. So it might be not so long until we get to see laptop servers or whatever devices with these CPUs. Yeah, well, Aurelian is an IRC, and he wanted to know that we build packages with the test suite enabled in RISC-V, unlike Motorola 68 port.
Anybody else?
So has anyone here played with RISC-V already, or?
So yeah, in that sense, I would recommend. Can we switch back to that? If you're just idly curious and you don't have tons of other packages to work on, or you're kind of looking for something to procrastinate on working on packages, you could build a RISC-V virtual machine running QEMU just to see that it works. We recently got the support. We got enough packages built that you can reasonably use just plain to bootstrap, and with from an x86 machine, you can, if you install like QEMU user static and a number of other steps, there are instructions on the wiki page. So I would encourage you to play with it if you have some time that you have, or you're willing to put in front of something else. You know, we're all busy people, but sometimes you want to see something different. So there you go. Should I start calling on people? Yeah. Aurelian mentioned on IRC, the dev board, it does happen to be expensive, but unlike a Raspberry Pi, it does have at least 8 gigs of RAM, which is, it's a bit of a consolation prize, I'd say. But it's, you want network storage because, well, yeah, the SD card support isn't great.
Yeah, with the Sci-Fi, there's a microchip development board, which is huge, a lot of components that provides you with PCI connectors through an FPGA, and it has SATA connectors as well through the FPGA, so you can have access to disks, and you can have a video card plugged in and have access to video.
And also from IRC, Carsten Merker mentions there's another development board in the works that should be considerably cheaper, and there's even preliminary U-boot support submitted upstream. So
from Microchip.
Yeah, the MPFS Icicle. So keep your eye out for that if you want to play with some more dev boards, and yeah, you're looking for something less than $1,000 for a toy. All right. Well, thanks for lending us your time and eyes and ears, and I hope we see a bright RISC-V future.